Morning.
Morning.
When are you guys going back to France?
On the 19th.
20th.
Okay, and how expensive were the tickets?
It was 130
No
for
way.
one leg, but then £35 for the other leg.
35 the way back?
Yeah.
Shut up. I haven't gotten mine already actually.
What are you waiting for?
I don't know. I should get them. Yeah. I'll take a flight.
It was quite hard actually because on the same day flights were like £40.
What are you doing for the holidays?
Going back to France tomorrow, actually.
Really? Did you get your ticket already?
Yes.
How much did it cost?
I'm
What are you doing for Christmas?
going back to France.
And how are you going to France?
I'm taking the train.
My eco-friendly flatmates buy expensive train tickets, but I think the government should do more to make green travel accessible. So I decided to analyze flight prices and train prices for travel between London and Paris this December. I used the Flight API to access the fare information. I had to navigate the JSON structure and extract relevant information thanks to this script. It was quite complicated because they really mess their information quite deep in there. Then I had to use a currency converter API to convert from dollars to pounds. For the train information, I wasn't able to find it online, so I had to use data scraping by building a bot, a crawler, that would use Selenium and Chrome driver to open instances of the browser and extract the relevant information. I found the class name associated with the fare price. However, on November 30th, they changed the HTML, so I had to inspect it again and change the script. This script returns the lowest price for a specific day, and same goes with the flights. I then had to use a cloud-based database. I chose ThinkSpeak for its simplicity to store all of the data. I have a channel for Eurostar, a channel for the Flight API, and then eventually a channel for the performance metrics. Each field corresponds to a day of travel, so I iterated through December 20th to 28th. So here you see the script runs by itself and goes through these days, updating the channel every time. The crawler tries to get a flight information 4 times before giving up. This handles the situation of the 25th of December when there are no trains. And in that case, it says there are no trains. Here's the Chrome tab that allows it to run autonomously every 4 hours. This script accesses the API information and plots it so trains in blue and flights in red. You can see that I changed the departure airport from Heathrow to Luton to access the more low-cost carriers. I chose to use soft actuation in the form of a bot so that it would provide interactivity with the user. So I built a Telegram bot and defined a few functions. These are triggered by command and text that the users can send. I used job queue to create an alert system that would run every 4 hours as soon as the user wrote set and stop when the user said unset. It would take in the flight and train data and let the user know if flights are cheaper than trains at the moment. A few other functionalities allowed the user to get the minimum price information for given travel dates and visualize how they've changed over time. The image of a graph was provided for this purpose. If flights were indeed cheaper than trains, the user had the option to protest by sending an email to their local MP requesting government action. Mine was Andy Slaughter, so I sent the emails to him. To test the functionality, I made myself the email recipient, and you can see that I received it. Finally, the user had the option to buy a train ticket and was then redirected to the Eurostar through a URL. These interactions were tracked to track user engagement. I wanted to analyze the performance of my system. I managed to improve reliability by 25% by making sure that the API fields were updated all at once instead of one at a time. To analyze how long data gathering took, I used a timestamp at the beginning and at the end of the code. It showed that the fastest times were in the middle of the night when everyone was asleep. This suggested that internet speed might be a factor, so I tried to track that too, but wasn't very successful in gathering data. I decided to run the sensing on my Raspberry Pi as well, so I could compare power consumption with my Mac, using CPU as a proxy, and found that my Mac used so much more power throughout the day and outside of runs because it was never allowed to sleep or the cron tab wouldn't run. Here's how my end system operated with and without the performance analysis. Thank you for watching.